All right, my name is Jamshik Hekabad, and this is my Physics 2211 Lab 4. The purpose of this lab is to analyze oscillating motion and the properties of the energy principle using the observations gathered by the tracker and video, and also comparing them to the experimental model that was used in GlowScript. As you can see here, the principles that I used are my period formula, my kinetic energy, potential spring energy, and potential gravitational energy, which is set for Earth since it's not since it's near the surface of the Earth. And then you have your energy total, which is the sum of all the energies acting upon the system. And then we have my gravitational force, and then we have spring force and the position and velocity update formulas. And this is my tracker video. As you can see, my initial conditions, I set the mass equivalent to 0.402 kilograms, and then my initial position being negative 0.127 in the x direction and negative 0.715 in the y direction, and 0 in the z direction, with my L being 0.7 meters, my velocity being initial velocity being 0 in all directions, and my spring constant that I calculated to be 6.88 Newton meters. Here's my GlowScript model. All right. Now here's my code that I used to get that model. The things we changed are we changed the ball.m, which is the mass of the ball, to 0.402, the initial conditions, the ball's position vector, to the values I gathered in the tracker video, negative 0.127 and negative 715, and then the ball's initial velocity to be 0, set the gravitational set G to 9.8 and the spring constant to 6.88 and the relaxed spring of the length to 0.127. And then I also edited the lines to get L, L hat, and S for the spring for spring. And then you can also see, to complete the initial energies of the system, we set up K, the kinetic energy, the gravitational potential energy, and the spring potential energy, and then sum those up for the total energy. And then here on the right, you can see calculated the gravitational force vector using the same formula in the principles. Also, you calculated the force of the spring, and then F net being the combination of the spring and gravitational force. And after that, we then re-updated the spring potential, gravitational potential, and the kinetic energy for each time period. And then also added delta UG, delta US, and delta K, the respective change in each of those energies to be updated throughout the model. And here's my graph that was produced from the model that represents the change in energy versus the time, the blue line being the kinetic energy, red being the change in potential gravitational energy, green being the change in potential energy of the spring, and then the orange being the change in the total energy overall. One thing I wanted to point out is that the orange line, which is the total energy or change in total energy, stays at 0 the entire time, which means it fills the energy principle because everything is at equilibrium and all of the stuff cancels out. Here you can also see the second graph, that was the position versus the time. The blue line being the model from the tracker video, and the red being the experimental gathered in the glow script. The errors could be unaccounted forces such as drag and stuff. And one thing I wanted to point out is that the max in the experimental, you could see that the max positions declined as it went on. And my post-lab questions, does it satisfy the energy principle? Yes, because the change in E is 0, as you can see in the previous graph shown. And then the estimates of oscillation, I estimated the period of oscillation for the X to be 1.638, and the period of oscillation for Y to be 1.519. And this means that they probably have two different amplitudes going in, the respective directions. And that's it.